For this video, we're going to go back over everything we've looked at so far in this unit because we have a test coming up in a few class periods. So to begin with, we started by graphing quadratics. Okay, now we have different forms that we graphed in. The first one we looked at was, or one of them that we looked at was standard form. Then we looked at a vertex form. And then a few days ago, we looked at intercept form. All of these forms have one letter in common, and that's A, and A always comes first. So for standard form, we have ax squared, then we have a b and a c. Vertex form, A comes first, and then we have an h and a k. And then intercept form, A comes first, and then we have a p and a q. So whenever we graph in either of these forms, okay, you've got to first find your most important point, and that's the vertex. The easiest one to get the vertex is vertex form. That's why we call it vertex form. So in vertex form, your vertex is just HK, whatever that point HK is. And you got to be careful that H is the opposite sign. So once you have your vertex, then you can find some other points by either making a table or finding your y-intercept, or if you remember that pattern, right, our parent function, we're at 0, 0, 1, 1, and 2, 4, and then we reflect all those points over. So that's our parent function without any stretching or compressing, so then you can use your A to determine what your new points need to be. So for example, if your A was 2, instead of going up 1 and write 1, I would go up 2 and write 1. And instead of going up 4, write 2, I would go up 8 and write 2. Right? But you just need at least one other point that you can reflect over so you can have 3 points, including your vertex, to graph the quadratic. For standard and intercept form, it's not as easy to get our vertex, and we have to start by finding the axis of symmetry. In standard form, your axis of symmetry, the formula for it is negative b over 2a. And that's referring to the A and B in standard form. Once you have your negative b over 2a, then you're going to plug it in to get the rest of your vertex. All right, your axis of symmetry is the x value of your vertex. So we're going to plug it in to get your vertex. And then there's another point we can easily get from standard form without having to do anything, and that's that c value, which is the y-intercept. So you find your y-intercept, which is 0 and whatever c is, and then you reflect it to get your third point. So we have our axis of symmetry to the vertex, find your y-intercept, reflect it, and then you have enough to get your parabola. Intercept form is very similar. You have to start by finding your axis of symmetry if you want to know the vertex. But for this one, our formula is p plus q over 2. And once you have your axis of symmetry, you plug it in to find your vertex. And in intercept form, you end up with 2 x-intercepts. Usually, sometimes you might only have one, but we have 2 x-intercepts that we're going to have as our other 2 points. And your x-intercepts are always your p and your q. And remember, p and q, p0 and q0, they're going to be opposite signs as well. Anytime we're dealing with parentheses, we're going to have the opposite sign. So if that was an x plus 2, it would really be a negative 2. Okay, so in standard form, your 3 points come from your vertex, your y-intercept, and the reflection. In vertex form, you have your vertex, but then you have to find at least 2 other points, and you can do that by making a table, using your y-intercept, or using the pattern we have from our parent function. In intercept form, you find your vertex with the axis of symmetry, and then you use your x-intercepts as your other 2 points. You always have the option of just making a table to graph anything, including these quadratics. These are just the shortcuts that allow us to get the important information, and that's it. Then we went into factoring, and we had several different methods of factoring. We start with the GCF. You always look for the GCF first in every type of factoring. No matter what, you always look for your GCF. Right? Then we talked about grouping, and grouping is when we have 4 terms. So if you see 4 terms, you've got to be thinking grouping. Then we factored trinomials, and with trinomials, we have 2 different types. We have one where a equals 1, which is what we call our plain Jane trinomial. And then we have where a is not 1. If a equals 1, we're just going to multiply to c and add to b. Okay, and that's when we're in our standard form, ax squared plus bx plus c. So a is 1, so we start with just x squared. We want to multiply to c, add to b. If a is not 1, it's not as simple anymore because we have to start figuring out what's going to multiply when we FOIL it out to get all three of those terms in our trinomial. So we have two options. One option is bottoms up, and one is the reverse box. I don't care which method you use, just make sure you are completely comfortable with one of these methods. Typically, if you like to multiply by FOIL, you tend to gravitate towards bottoms up. If you like to multiply with the box method, you tend to like the reverse box method. Doesn't matter, they do the same thing. As long as you do correctly, you'll get the same outcome. And then we also looked at our difference of squares patterns. Difference of squares is when you have two terms. So as soon as you see two terms, you've got to be thinking this could be difference of squares. But it's got to be a difference, which means you've got to have subtraction. And it's got to have perfect squares. Alright, which means we can take the square root of them. Remember, with perfect squares, a variable can be a perfect square as long as it has an even exponent. Right? And then you just cut it in half. So the square root of x to the 10th would be x to the 5th. And then you need to be able to at least recognize our perfect squares up through at least 15. Right? 1 through 15, be able to recognize if it is a perfect square or not. Then we talked about solving quadratics, and we have two ways of solving that we've done in our class. There are other ways, but we've just looked at two. Right? One is to solve by graphing. Alright, and remember we have those four words that mean the same thing. We have solution, which we get when we solve something. We have root, 0, and x-intercept. Alright, so all of these mean the same thing. So when I solve a quadratic, I'm finding my x-intercepts. So if I graph a quadratic, wherever those x-intercepts are, those are my solutions. So you can graph whatever quadratic you have, find your x-intercepts, and that's how you solve it. The other method we looked at was solving by factoring. And to do that, we take our factors and set them equal to 0. So for example, if I factored something out and got x plus 5 times x minus 7. Remember the zero product property. In order to multiply to get 0, at least one of those terms has to be 0. So we set both of these equal to 0, and we get x equals negative 5 and x equals 7. So we have solving by graphing, solving by factoring. And then the last thing we looked at is writing equations when you're given some points, as well as going between your different forms. Okay, so remember, standard form has no parentheses. So if you're trying to get to standard form from intercept or vertex form, you're just going to multiply it out. And then in vertex form, you need to know your vertex. And then you can just plug in your h and your k. And then the a is the same in all three forms. In intercept form, you need to know your x-intercepts. And it's also factored form. So if you're in standard form, you can factor it out to get to intercept form. And then like we just said, standard form, you just multiply. Take whatever vertex or intercept form you're given and multiply it out. And that's how we go back and forth between our different forms. We also talked about writing equations, right? It's similar to the slope-intercept form we looked at, where you find everything except one value. In our case, we can't find a until we plug in x and y. So for example, if I know that I figured everything out and I got as far as a times x minus 1 times x plus 2, and I know that this information goes to the point 4, 1. Well, I can take my x, take my y, and plug it in. So 1 equals a times 4 minus 1 times 4 plus 2. 4 minus 1 is 3, 4 plus 2 is 6, 3 times 6 is 18. So I have 18 times a, divide by 18, and we get a equals 1 over 18. So then my equation would be y equals 1 over 18 times x minus 1 times x plus 2. Right? So you use the x and y that you have to find a. Another option is when we're given maybe 3 points, like 1, 5, 3, 7, and 6, negative 2. Okay, we can do it in the calculator, right? You go to Stat, Edit, put your x's in L1, your y's in L2, and we go Stat, and we scroll over to Calc, and this time we're using number 5 for our quad regression, right? And then it'll give you the equation for you. Okay, so all of this stuff is what we've covered over the last few weeks, and it's a lot, but it's all intertwined together, and it all feeds off each other. So make sure that you're comfortable with every step of the way.